We looked at records and stuff recently. Not like super recently, but like within the this era. We looked back at records to see where it really came from and who and things like that. It's very interesting. All right, so to start with the Pythagorean Theorem, the first thing that we need to do is we need to talk about a right triangle. What is a right triangle? A triangle with how many angles are 90? How many are 90 degrees, though? With one angle that's 90 degrees. Okay, so let's draw that over here. I'm going to draw my 90-degree angle first. All right, we have some special terms for our sides of a right triangle. Okay, the most important side of a right triangle is going to be the hypotenuse. Hypotenuse. And the hypotenuse is across. How do you spell across? 1C or 2? 1. From the right angle, or from the 90-degree angle. So in this case, the hypotenuse, if I look at this, it goes across from that right angle. If I draw an arrow going through the triangle, this side is my hypotenuse. Okay, the other sides are called legs. And the legs are the two sides that create the 90. So where that 90 degree comes together, where that box is in that corner, those two sides are the legs. So we have one leg and another leg. All right, so the Pythagorean Theorem tells us that if I have a squared plus b squared, that's going to equal c squared. What's really important about A, B, and C is A is a leg, B is a leg, which means if I have two legs, what's the last side going to be? Okay, A squared plus B squared equals C squared. That's that Pythagorean theorem. And this only works for right angles. Or sorry, right triangles, not angles. We are going to do two examples of this. And then you have the rest of the time to work, which will be great. See a lot of people still writing this down, so make sure you get that all written down. Alright, so for example 1, we're going to draw a right triangle that goes this way, so if you want to watch it first. We're going to draw our own right triangle there. I know that this side is 8 kilometers, so km for kilometers. This side is 15 kilometers, so 15 km. And I'm going to put this as x. So we need to find x. That's our goal. Alright, first thing I'm always going to ask myself is which one is the hypotenuse? Is it the 8, the 15, or the x? In this case, the hypotenuse is across from the 90, so it's x. Which means my other two are called what? Legs. So in my equation here, a squared plus b squared equals c squared. Where does that hypotenuse go for A, B, C? So A and B are my legs. It doesn't matter which one goes where, as long as those legs are my A and my B. Because remember, we can always switch those around. We could do B squared plus A squared, but that just sounds silly. Alright, so what number are we going to use for A? What is one of my legs? 8. So 8 squared plus, what is my B? 15 squared equals, what will be my C? The x. Alright, now we're going to think, what is 8 squared? 8 times 8? Anyone know? 64. 15 times 15? Anyone? No one? That's okay. We can use our handy dandy calculator. 15 squared, 225. Equals x squared. Okay. Okay. I don't have it. I can write it on a post-it or something. Alright, what is 64 plus 225? 289. Now we might feel like that's our hypotenuse, but remember that's x squared. And we talked a lot about this squared in that last lesson. How do we undo a squared? Square root it, yep. If I square root one side, we square root the other. So the square root of 289 is 17. Okay, so my final answer, though, if I want to label it, it'd be 17 what? Kilometer. Alright, we're going to do one time to work. Alright, so number 2. You want to watch how it gets drawn first, you can, or if you just want to draw a right triangle and then might have to rotate it. I'm going to draw it like this time. This is my 90, and that's going to go across here. I know that this leg here is 7.9 centimeters, so cm. Thanks again. 7.9. Oh. Shucks.
Yeah.
Okay. And then we know that this side here is 16.7 centimeters. And our last side here is x. Alright, so we're going to use our Pythagorean theorem because we squared. So before I plug in my information, I'm going to identify which parts are my legs and which parts are my hypotenuse. Hypotenuse is across from the 90. So here's my 90 degree. I'm going to go across. Which side is my hypotenuse? 16.7. So which part is that going to go in for? A, B, or C? C. Which means the other two parts, what do we call these parts? Legs. Good. And the legs go in for A and B. It doesn't matter for which one or the other. So what should we put in for A?
7.9.
Sure, 7.9 squared plus, we don't know our x. Yep, x squared equals 16.7 squared. Our goal here is to solve for x, but before we start solving for x, we want to be able to simplify our sides. So what actual math can I do over here before I start solving? Not quite yet. You're right, we are going to subtract, but before I do that, we're going to do our 7.9 squared. 2.41, or 62 and 41 hundredths, plus x squared equals, and we're going to actually find that ourselves too. 16 squared is 278.89. Then what? What? Somebody said something. Oh, subtracting. Good. Subtract 62 and 41 hundredths. If you really wanted to be fancy, you could do that by hand. I'm not fancy, so I'm going to just do it on my calculator. 216.48. Is that the length of my hypotenuse? Centimeters? No. And we weren't even finding the hypotenuse, so that was just a totally wrong answer in general.
What do we still need to do with our last step?
And then that will be our hypotenuse, right? No. So square root, and I'm just going to hit that A and S button. Those calculators, you don't have to type it in. We are going to round to 2 decimal places today. So 2 after the decimal point. So do we want this to be a 71, or should we round up to 72? 71. Good. Is that the length of our hypotenuse? No, because what's the length of the hypotenuse? 16.7. This is just one of our legs. I'm going to throw in cm afterwards so that I know it's centimeters, but otherwise that is it.